10, lesson 35. We are solving quadratic equations, part 1. First one that they're asking about is find the zeros of the quadratic function. Well, what that is talking about is when you set this equation equal to 0, what do you get? Well, your first step is to set it equal to 0. So how are we going to do that? If you have an f of x here or a y here, you can just put a 0 in for that and then be able to solve the equation. Alright, well from here there's two different ways to do it. Most of you, I think, are going to try and get this x squared by itself. So you'd add 64 over, and then you'd divide by 9. So we would have 64 ninths equals x squared. Now I would tell you not to simplify that yet, because to get x squared, or to get x by itself, we're going to take a square root here. So x square root of 64 is 8, square root of 9 is 3. The only thing to remember, because there's a 2 here, we can have up to 2 answers. We do have 2 answers for this. Whenever you take the square root of a number, you're doing plus or minus. So your 2 answers are positive 8/3 and negative 8/3. Alright, now for the next one, we can still set a 0 in there. But this time, because we have an x squared and an x, we actually have to factor this out. Alright, and we could have done this over here with this one. This is the difference of 2 squares, so this could be 3x minus 8 and 3x plus 8. Set both of those equal to 0, you do get the same thing here. So you can do that one either way, but because we have an x squared and an x here, we have to factor this. So the only thing we can do here is take an x out, so we have x minus 5. Alright, and then we set both of our factors equal to 0. So x equals 0 and x minus 5 equals 0. Solve this one for x. X has to equal 5. So our answer for this is 0 and 5. Alright, coming down here to this bottom one. It's not set equal to f of x or to a y, so we're going to make it set equal to. Well, that means we either move this over here or these two things over there. I like to keep my x squared positive, so I'm going to move these two over to the left side. So I've got x squared minus 3x plus 28 equals 0, and then you just have to factor it out from there. So x and x. Both signs are the same, they're both, sorry, this should be a negative 28, not a positive 28. Let's fix that really quick, and this should be a positive 3, not a negative 3. Alright, this says our signs are different, so one's plus, one's minus. What multiplies together give us 28, adds together give us 3. Well, 7 and 4 multiply together to give us 28. 7 here and 4 there give us a positive 3. Remember to check it. Outers, negative 4x plus 7x gives us that 3x. So then we set those equal to 0. X equals negative 7 and positive 4. Alright, every single one of these you can plug back in to the equation and you should get a 0 out of there. Okay, or you should get both sides equal the same thing. If we plug this negative 7 in here, we get 49 equals 21 plus 28 is 49. Plug a 4 in, 16 equals negative 12 plus 28 is 16 also, so that does work. Okay, so if you want to check, plugging it back in will help you out with that. Alright, now this one, it says graph the equation and then state the roots of the equation. Alright, well the first thing I see is we have an x squared here, so that tells me it's a parabola. Alright, I don't know what the roots mean yet, so let's just graph it out and see what happens. We know it's going to be a parabola. We know it's going up because our a value is positive. We just have to find the vertex. Remember, to find the vertex, the x value of it, it's negative b over 2a. So our b value here is negative 10. So we'd have a negative 10 over 2 times our a value is 1. So 2 times 1. So we'd have 10 divided by 2 is 5. So our x value of our vertex is 5. Plug it back in to find our y. And remember, yeah, we don't have a y, but because that's 0, we can change that to a y. So we've got 25 minus 50 is negative 25, plus 25 is 0. So our vertex, 1, 2, 3, 4, 5, 5, 0, there's our vertex. From there, we just have to graph it out. Now remember, you can do an XY chart if you need to. Alright, so you plug in 6 and we get 36 minus 60 is negative 24 plus 25 is 1. Okay, so we're going over 1, up 1, and remember because our a value is 1, our pattern holds over 1, up 1, over 2, up 4, back 1, up 1, back 2, up 4, and there is our parabola. Then it says, state the roots of the equation. Well, the roots are the same as the zeros. The zeros and the roots are the same as the x-intercepts. Where does it cross our x-axis at? Well, our x-axis is simply at 5. So stating the roots of the equation for this one, it is 5. You can just have 1. In this case, when it bounces off the x-axis like that, they just double up. So that's why we only have 1 there. If we go to our next one, we do the same thing. Let's make that a y. Then negative b over 2a. So negative 20 over 8. Simplify that down, we get negative 5 halves. Right, and then plugging that into the equation, we get 4 times negative 5 halves squared plus 20 times negative 5 halves, and I get something that I don't think is correct. Oh, I know what I did. I put it into my calculator and I didn't put parentheses around the negative 5 halves when I squared it, so the calculator gave me something completely wrong. Okay, that one looks much more realistic. We have negative 5 halves and negative 25. Alright, so how do we graph that? Well, what I would say is for my y, I'm going to make each box worth 5 so I can get it on there. Okay, and then for x, I'm just going to make it worth 1. So, over 2.5, down 5. Alright, then from there, we've got to have some other points. So, and this is where we are going to have to use the xy chart. Remember, negative 5 halves is the same as negative 2.5. So I'm going to go negative 2, negative 1, negative 3, and negative 4. Negative 2, that would be, let's see, 4 times 4 is 16. 16 plus negative 40 would be negative 24. Negative 1 would be 4, negative 16. Alright, here we would have negative 24 and negative 16 also. Alright, so this one's going to be kind of messy to actually graph here. Negative 2, 24, negative 1, and negative 16. So something a little bit wider than what we normally have. Okay, so I graph it out, I get those 5 points. What the heck is that supposed to be? Well, sometimes it's just simpler to do what we were doing on the last page. Because if we come back here and we say, all right, it says find the roots, that means find the x-intercepts, set it equal to 0, it already is, factor out what you can, and then we've got x plus 5 equals 0. That would be really good if I put the points on the right side. Negative 2.5, negative 25. And then I'm here and there and there and there, which looks much more like the XY chart that I had. All right, we set both of these equal to 0. X equals 0, and x equals negative 5. So then, because of that quick math, I can actually find, well, it goes right through those 2 points. There's my graph. Here are my roots. Technically, when you do these, okay, I've always said do 5 points, but really all you need is 3. Find the vertex, and then find your 2 x-intercepts, and then you can be done. So this would be a much faster, easier way to do it after you've already found your vertex. All right, next one. Write a quadratic function that has zeros of 2 and negative 1. So I am telling you for this one that x equals 2 and x equals negative 1. Give me the equation that works for it. Well, before I can do that, I need the factors. Well, to get a factor that where x equals 2, technically all I have to do is move the 2 over. So I'm subtracting 2, and I'm adding 1 here. Well, here's the one factor, there's the other. If I multiply those together, will I get a quadratic function? Sure I will. So FOIL it, so I've got x squared minus, let's see, plus x minus 2x, so minus x minus 2. And there is the expression, when factored down, gives us zeros of 2 and negative 1. The only problem is it's not a function yet. Actually, that's not even a function either. That'd be an equation. Our function is right there. And then it is done. All right, for our next one, write a quadratic function that has zeros of negative 3/2 and 4. Well, I can already write that down as part of my answer. I know that x equals negative 3/2 and x equals 4. So what I could do here is I could say, well, x plus 3/2 and x minus 4, those both equal to 0. Then I can multiply those together. I don't want to multiply by this 3/2 though, okay? What else I could do is I could multiply this entire equation by 2. So I'd have 2x plus 3 equals 0. If I solve this one here for x, subtract 3, divide by 2, I still get a 0 of negative 3/2, like how I started. So that is perfectly fine to do. Then I can multiply that by x minus 4. And that is a lot easier to do now. So 2x times x is 2x squared. 2x times negative 4 is negative 8x, plus 3x, so negative 5x, minus 12. There's my equation. Now let me ask you this. Could I also have 12x squared minus 30x minus 72? If I solve this thing, could I also get answers of negative 3/2 and 4? Absolutely I could. And the only difference between these is I multiplied this one by 6 to get that. Okay, if I divide by 6, I'd be back to this, and then I could solve it just like I did before. Okay, or if you set this equal to 0, factored it down, your first step would be to take out a 6, then you're right back to this thing, and then you'd end up solving it to get down to those two answers. Alright, so for these you can have multiple answers, okay? Just pay attention to what the question is asking. Last one, a height. The height of a free-falling object is given by the function h of t equals negative 16t squared plus v sub o times t plus h sub o, where h sub o is the initial height, v sub o is the initial velocity, and h of t is the height in feet at time t seconds. How long does it take for an object to hit the ground after it is thrown straight down at a speed of 12 feet per second from a height of 108 feet? Well, let's put in what we know. We know the initial height is 108 feet, so that's h sub t. Negative 16t squared, that doesn't change. Speed of 12 feet, well, that's our velocity. So, plus 12t. H sub o, well, that is backwards. H sub o is supposed to be the initial height. So, plus 108 over here. And h of t is the height in feet at time t seconds. I was right the first time. Sorry. The 108 does go over here. That is the one more time. Put the 108 over here. Put the 0 here. And now the question is, how long does it take for an object to hit the ground? We just have to solve for t. Well, let's make this easier on ourselves. We can divide this whole thing by 4. So we've got 0 equals, and I'm going to divide by negative 4 to make this thing positive. So I've got 4t squared minus 3t minus 27. Alright, not super easier, but it does make things a lot easier to deal with here. Things we know. We've got a t in both of these. One's going to be a plus, one's going to be a minus. Okay, for 4 it's either 1 and 4 or 2 and 2. For 27 we got a bunch, don't we? 1 and 27, 3 and 9, 9 and 3, 27 and 1. Okay, so not too bad. How do I get a negative 3 in the middle? Let's see. Let's try 1 and 4 and 3 and 9. We get a positive 9 minus 12 is negative 3, which is what we're looking for there. Now, we just have to set these equal to 0. T minus 3 equals 0, so t would equal 3. 4t plus 9 equals 0, subtract 9, divide by 4, negative 9 fourths. Alright, so what's our answer? Well, t stands for time. We can't have a negative time, so our answer is 3 seconds. Alright, so that's how you would solve those. Just be aware of where things go in, and then you just factor it down from there, like we did the rest of the day. Any questions, please let me know.